Have you ever looked up at the sky and just wondered, why blue? Why not green or purple? And why does that perfect blue turn into a fiery masterpiece of reds and oranges at sunrise and sunset? It seems so simple, but the science behind it is actually fascinating. And today, we're going to break it all down. It all starts with our sun. Sunlight might look white or yellowish to us, but it's actually a mix of all the colors of the rainbow, like a giant cosmic prism. Each color travels as a wave, and they all have different wavelengths. Violet and blue have short, choppy waves, while red and orange have long, lazy ones. Now, imagine these light waves on a journey to Earth. Their final destination is your eyes. But first, they have to get through our atmosphere. Our atmosphere isn't empty. It's filled with tiny gas molecules, water droplets, and dust. Think of it as a massive, invisible obstacle course for light. This is where a cool phenomenon called Rayleigh scattering comes into play. It's a fancy name for what happens when light hits particles that are much smaller than its own wavelength, like the nitrogen and oxygen molecules in our air. Here's the key. These tiny molecules are much better at scattering the short wavelength colors. So, as sunlight enters the atmosphere, the blue and violet light waves get bounced around in every direction like a pinball machine. They scatter all over the sky. Because our eyes are more sensitive to blue than violet, the whole sky appears blue to us. It's like the atmosphere is painting the entire dome above us with scattered blue light. Meanwhile, the longer wavelength colors like red, orange, and yellow are not so easily scattered. They tend to travel in a more or less straight line right through the atmosphere. That's why when you look directly at the sun during the day, it appears yellowish-white too, seeing a mix of all the colors that made it through without being scattered away. So, if that's why the sky is blue during the day, what changes at sunrise and sunset? Well, it's all about the angle. When the sun is on the horizon, its light has to travel through much more of the Earth's atmosphere to reach you. It's like taking the scenic route instead of the direct one. This longer journey means the light encounters way more air molecules and atmospheric particles. The blue light gets scattered so much that it's pretty much all gone before it even gets close to your eyes. It's been bounced away from your line of sight. But what about those longer, more resilient red and orange waves? They power through the extra atmosphere. They get scattered a little bit, but most of them make it directly to you. The result, the light that reaches your eyes, is dominated by these beautiful warm colors. And it's not just the sun that looks red. These long waves also illuminate the clouds and haze near the horizon, creating those breathtaking fiery skies we all love to watch. So, from the calm blue of midday to the passionate reds of dusk, the color of our sky is a beautiful story told by light on its incredible journey through our atmosphere. It's a daily light show, courtesy of physics. Next time you're admiring a sunset, you'll know exactly why you're seeing that stunning display of color. Thanks for joining me on this colorful journey through our sky. If you found this as amazing as I do, hit that like button and subscribe for more deep dives into the wonders of our world. See you in the next video.